We shall now discuss with some more examples on sandwich theorem. Consider the limit whatever you call greatest integer function or step function or integral part function, integral part of x, integral part of 2x plus integral part of 3x and so on etc. up to integral part of nx by n square as n tends to infinity. We are supposed to have, look here, by the definition of integral part itself, we know that nx minus 1 less than integral part of nx less than or equal to nx. By the very definition of integral part of nx, we will be able to have this step. Now, you take n is equal to 1, 2, 3 and so on. You observe the steps. What happens? You taking n is equal to 1, we have 1x minus 1 less than integral part of 1x less than or equal to 1x. Next, n is equal to 2. You take n is equal to 2. What is going to happen? 2x minus 1 less than integral part of 2x less than or equal to 2x. Again, n is equal to 3. 3x minus 1 less than integral part of 3x less than or equal to 3x. Like that, n is equal to 3, 4, 5 and so on etc. You now recall the step with the n in the place of n itself. What happens? nx minus 1 less than integral part of nx less than or equal to nx. Now, let us add all these inequalities. What is going to happen? 1x plus 2x plus 3x plus 4x plus 5x and so on nx is 1 plus 2 plus 3 plus etc. n into x minus n less than. Now you see, let me call this step the numerator of the required one by some Sn. If you add all these things, what is going to happen? Sn less than or equal to 1x plus 2x plus 3x plus etc. etc. nx. Again it is equal to 1 plus 2 plus 3 plus etc. n into x. Okay, 1 plus 2 plus etc. plus n is nothing but sum of the first n natural numbers sigma n. It is nothing but n into n plus 1 by 2. Therefore, n into n plus 1 by 2 into x minus n is less than Sn is less than or equal to n into n plus 1 by 2 into x. We shall now encash this last step to have the required limit. My dear friends, just to have a clear-cut explanation only, we could have drawn all these steps, but every one of these can be observed in our mind itself. Not only that, you will be able to arrive at this step immediately. Yes, of course. Well, next one. I'll be making use of this last step. To continue further, I will like to remove all these three steps. Divide on all the sides by n square. What is going to happen? N into n plus 1 into x by 2n square minus n by n square is less than Sn by n square is less than or equal to n into n plus 1 by 2n square into x. And now it is a very easy matter to see that this tends to, come on, n and n will go away, n and n will go away. This is n by 2n, this approaches x by 2. isn't it? 1 by 2 into x, that is x by 2 minus n by n square is 1 by n. As n tends to infinity, it tends to 0. X by 2 minus 0. Now, this tends to, we have discussed with the limit of this extreme left part. Now, extreme right part, what happens to that? N plus 1 by 2n. As n tends to infinity, it tends to half into x, x by 2. So, let me take this f of x, that h of x, and the middle one g of x. Recall the definition of sandwich theorem, the statement of sandwich theorem. F of x less than or equal to g of x less than or equal to h of x. The first one and the last one, namely f of x and h of x, tend to the same limit. Then the middle function should also tend to the same limit. Therefore, this also must tend to x by 2. Thereby, you will be able to have the answer as x by 2. This is the direct usage of sandwich theorem. A beautiful application of sandwich theorem. One more thing is also there involving these integral parts. Another famous and standard question is there. Let us now go through that. If r is a natural number, integral part of 1 power r into x plus integral part of 2 power r into x plus etc. Integral part of n power r into x by n power r plus 1. How to get this limit? How to get this limit? By making use of the sandwich theorem again, we are able to have the answer as x by r plus 1. How can it be? Let us see. See, this can be taken as limit as n tends to infinity sigma k power r into x k is equal to 1 to n by n power r plus 1. Isn't it? By n power r plus 1. To have this lengthier sum, instead of having this lengthier sum, I have made use of a symbol of summation, that is sigma k power r into x, integral part of k power r into x by n power r plus 1. Now let us see, by the definition of integral part of a function, k power r into x minus 1 less than or equal to integral k power r into x less than or equal to k power r into x. Isn't it? In general, by the definition of integral part, we definitely have such things. Now, let us use sigma notation, that is sigma k power r into x minus 1, k is equal to 1 to n less than or equal to sigma k is equal to 1 to n k power r into x less than or equal to sigma k power r into x. Of course, this is pakka less than k is equal to 1 to n. Now you observe the required limit. In the required limit you have by n power r plus 1. You divide this inequality on all the sides by n power r plus 1. What is going to happen? Sigma k power r into x minus 1 by n power r plus 1 less than sigma k is equal to 1 to n sigma k power r into x integral part of by n power r plus 1 is less than or equal to sigma k power r into x by n power r plus 1. Well, you observe this one. As n tends to infinity, what is the limit of this expression? Extreme left, and that of the quantity present on extreme right of that. Let us calculate first of all. Just nothing but we are making use of sandwich theorem, that's all. To make the situation very clear so that application of sandwich theorem can be done. Okay, consider this. Extreme left is limit as n tends to infinity x into sigma k power r by n power r plus 1 minus 1 by n power r plus 1. Well, my dear friends, for the present, you please believe that the limit of this is 1 by r plus 1. I shall prove at the end of this problem. I shall prove it can easily be observed, of course. This is 1 by r plus 1. Therefore, this is x by r plus 1 minus 1 by n power r plus 1 as n tends to infinity. What is the limit? It is 0. So, the quantity which lies at the extreme left of that one tends to x by r plus 1. What about the quantity that which lies at the extreme right of the expression? Just like this, you pull x out from that sigma notation. X into sigma k power r by n power r plus 1 is again x by r plus 1. Now the situation is very clear. It is very clear so that we will be able to use sandwich theorem. This tends to x by r plus 1 and that also tends to x by r plus 1. Hence the middle number, middle function, that is the required limit, must also tend to x by r plus 1. Ultimately, what will be the answer for this? This is nothing but x by r plus 1. It's nothing but x by r plus 1. And from this, we can observe so many limits. That is sigma 1 square into x plus sigma integral part of 1 square into x plus integral part of 2 square into x plus integral part of 3 square into x, etc., etc., integral part of n square into x by n cube. What will it be? It will be x by 3. You are replacing r by 2. r by 2. And again, the previous problem can also be viewed from this. You take just r is equal to 1, what happens? Integral part of 1x plus integral part of 2x plus integral part of 3x and so on, integral part of nx is, you take r as 1, x by 1 plus 1 is x by 2. Of course, previously we could have done, the answer was x by 2. It can be observed from this also. Well, to agree with this answer, we must be satisfied with the explanation that sigma k power r by n power r plus 1 k is equal to 1 to n tends to 1 by r plus 1. How? How can we agree with that? Is it true or not? Let us verify. From the earlier knowledge of limits, we know that limit as n tends to infinity 1 plus 2 plus 3 plus etc. plus n by n square is 1 by 2. Limit as n tends to infinity 1 square plus 2 square plus 3 square plus etc. etc. n square by n cube is 1 by 3. Limit as n tends to infinity of 1 cube plus 2 cube plus 3 cube plus 4 cube plus etc. n cube by n power 4 is 1 by 4. Limit as n tends to infinity 1 power 4 plus 2 power 4 plus 3 power 4 plus etc. n power 4 by n power 5 is 1 by 5. Limit as n tends to infinity 1 power 5 plus 2 power 5 plus 3 power 5 plus etc. n power 5 by n power 6 is 1 by 6. And in general, limit as n tends to infinity 1 power r plus 2 power r plus 3 power r plus and so on n power r by n power r plus 1 is 1 by r plus 1. Actually speaking, these three are the applications of this result. If you take r is equal to 1, this problem and that answer can be obtained. If you take r is equal to 2, this problem and that answer can be viewed. If you take r is equal to 3, this question and that answer can easily be observed. Is it the way of generalizing or is there any theoretical proof for that? Yes, of course, a wonderful theoretical background is there to say this is true or this is correct. What is that background? Actually speaking, the explanation for this will be dealt with in definite integrals. We are supposed to make use of integration as the limit of a sum. Of course, you need not wait up to that chapter. You can understand this in the beginning itself. If at all there is any limit like this, you observe that as 1 by n into sigma r is equal to 1 to n f of r by n. If there is any sum which occurs in this form, then the process which is going to be discussed in definite integrals or integration says that limit as n tends to infinity of this sum is nothing but integral 0 to 1 f of x dx. You please observe, in the place of r by n, you are replacing x. Okay, r changes from 1 to n. Then x changes from 1 by n to n by n. 1 by n, its limit is 0. So 0 to 1 f of x dx. Yes. Now, how can that be made use of to obtain this limit? Let us try. It's very simple. Within one step or there, we'll be able to have the answer. How can it be done? At this moment, of special interest is the case to deal with this limit. Now, this limit, I like to say some L. What is the fate of L? Let us observe. L is equal to limit as n tends to infinity 1 by n into one power r plus 2 power r plus 3 power r plus etc. n power r by n power r. Correct? Correct. This is equal to limit as n tends to infinity into 1 by n into sigma k by n whole power r, k is equal to 1 to n. Of course, in the place of r in the standard result of integration, we have k here. 1 by n into f of k by n. Instead of f of r by n, we have f of k by n. So, it is just nothing but integral 0 to 1 integral 0 to 1, this is f of x, that is x power r dx. What is integral of x power r? X to the power of r plus 1 by r plus 1 between the limits 0 and 1. If you take 1 in the place of x, it will be 1 by r plus 1, and if you take 0 in the place of x, it will be 0. Hence, the answer will be 1 by r plus 1. 1 by r plus 1. 1 by r plus 1. Yes. Therefore, it is very easy to believe that this answer is correct. This limit is 1 by r plus 1. Moreover, at so many occasions, as and when you come across 1 power r, 2 power r, 3 power r, like that, n power r by n power r plus 1, you will be able to use of 1 by r plus 1. Yes. At so many situations, we look at such limits. As an example, limit as n tends to infinity, 1 power 6 plus 2 power 6 plus 3 power 6 and so on plus n power 6 by n power 7. Answer please. 1 by 7. Because we have r is 6. 1 by r plus 1 is 1 by 7. Like that. So, by knowing an application of sandwich theorem, luckily we are able to know a particular procedure. This is of course called integration as the limit of a sum. Yes. While discussing with the application of the sandwich theorem, Previously, we could come across one important question. Let us recall that question once again. Let us consider the limit. Here is also we are able to have a big sum. Some students may think of it in a wrong way. Oh, sandwich theorem might be used here. I'm sorry to say that the procedure is wrong. Why? Because you just add n in the numerator to the first term and find the limit. N by n plus 1, n by n plus 1 tends to 1. Think of the same in view of the last one. You add n in the numerator and find the limit of the last term, n by 2n. n by 2n is half. If you proceed in that way for the first term, you did get it as 1. But if you do that in the view of last one, you are getting half. They're not same. Therefore, sandwich theorem cannot be used here. Cannot be used here. Then what should you do? As we have the previous procedure. What is that procedure? Integration as the limit of a sum. We are going to use it. How? You observe that. Limit as n tends to infinity 1 by n into 1 plus 1 by n plus 1 by n into 1 plus 2 by n plus 1 by n into 1 plus 3 by n plus 1 by, what can you say about 2n? It is n plus n. n into 1 plus n by n. Now, let me bring 1 by n out. Limit as n tends to infinity 1 by n into, come on. You read the remaining part. 1 by 1 plus 1 by n, 1 by 1 plus 2 by n, 1 by 1 plus 3 by n, 1 by 1 plus 4 by n, 1 by 1 plus n by n. You can write that as sigma 1 by 1 plus r by n, isn't it? Of course, r runs from 1 to n. 1 to n. You observe. This is absolutely as in the shape of the previous formula, or rather procedure of integration. What is that? 1 by n into sigma f of r by n, limit as n tends to infinity, is equal to integral 0 to 1 f of x dx. Of course, those limits of integration will be decided according to the boundaries of small r, from where to where it ranges. According to that only those limits 0 to 1 can be decided here. Like that, this is f of r by n. In the place of r by n, you can replace x, so that it is 1 by 1 plus x. Hence, this is integral 0 to 1, 1 by 1 plus x dx. We all know that it is ln mod 1 plus x. You need not use modulus symbol. Why? Because x ranges between 0 to 1 only, hence it is non-negative. Therefore, it is log 1 plus x between the limits 0 to 1. Take 1 in the place of x, you are getting it log 2. Take 0 in the place of x, you get is log 1 as 0. So it is log 2 minus 0, hence it is log 2. Therefore, the entire answer for this question is log 2. Log 2. We could have known a procedure. Let us think of its reusability. Can it be used again to observe a similar problem of this sort or not? Let us see. With a small change in the previous problem, we are able to observe this problem. Previously, that is in the latest problem, the last term was 1 by 2n, but here it is 1 by 3n. 1 by 3n means n plus 2n. By proceeding exactly and absolutely in the similar fashion, you can convert this as limit as n tends to infinity 1 by n into sigma, come on, think of n into 1 plus 1 by n plus 1 bar 2 by n plus 1 plus 3 by n plus 1 plus 4 by n and so on, etc. 1 plus 2n by n, isn't it? Therefore, again it is 1 plus r by n, r running from 1 to 2n because the last term is that. Now, the limits of integration will change. How should they be changed? How can they be changed? Look here, this is integral of f of x dx, that is okay. In the place of x, we take r by n, that is 1 by 1 plus x, that is okay. What is the lower boundary of r? R is equal to 1. As n tends to infinity, 1 r by n. We are supposed to fix the limits of integration for x. X means r by n. R means for the lower boundary it is 1. R by n means 1 by n. 1 by n tends to 0 as n tends to infinity. Hence the lower limit is 0. Okay. What do you say about the upper limit? Upper limit is 2n. R is 2n. R by n is 2n by n. 2n by n. It is 2. Integral 0 to 2. And you proceed as before. 1 by 1 plus x is nothing but log mod 1 plus x to the base c. And if you substitute the limit 0 and 2, that is upper limit 2 and 0, then you will be able to have log 3 to the base c. Or ln 3. Previously we had 1 by 2n, answer was log 2 to the base c. Now we have 1 by 3n, answer is log 3 to the base c. If I have 1 by 4n, then the limits will be r is equal to 1 to 3n. Here the limits will be 0 to 3, then the answer will be log 4. If it is 5n, the last step is 5n, log 5. The last step is 1 by 6n, log 6. If the last step is 1 by kn, the answer will be log k to the base c. We can generalize this result. Therefore, if this is some k, then it is log k to the base c. What will be the fate of the limits here? 1 plus r by n. R is running from 1 to because kn is nothing but n plus k minus 1 into n. If you get n out, it is 1 plus k minus 1 by n. K minus 1 only. K minus 1 into n by n. That is why r runs from k to 1 to k minus 1. K minus 1. Hence, the answer will be 0 to k minus 1. 0 to k minus 1. Hence, it is k minus 1 plus 1 is log k to the base c. So, like that, we generalize the result to be, what is the answer? Log k to the base c. It is log k to the base e. Likewise, we can solve we can find so many limits also which appears to be an application of sandwich theorem, but not. At certain cases, at some particular cases, such particular cases, we are supposed to use integration as the limit of a sum. So many situations and so many problems we come across, of course, in the due course of time. Let us now observe the next model of problems. Thinking of the numerical problems, what are all the general models which are present in the list of important problems? They will be limits that can be obtained in these following models we are supposed to discuss with. Direct substitution, Factorization method. Rationalization method. Limits using standard formulae. Infinite limits. Limits involving indeterminate forms. Like 1 power infinity, 0 power 0, 0 power infinity, infinity power infinity, like that. Such things are said to be, are supposed to be dealt with under the heading indeterminate forms. In those indeterminate forms only, and in so many other cases also, we'll be making use of a beautiful rule called L'Hospital's rule. L'Hospital, the name of a famous mathematician, he could present us a beautiful rule, which will be of course discussed in due course of time. And these are the only ways we cannot say. There might be other ways also, like expansions, using limits using expansions, limits using exponential functions, like that. So it is not convenient, of course, to classify all those things. In general, these are the varieties, and those problems which do not come under this type of heading can also be discussed. Let us now follow some order. First of all, direct substitution. Nothing can be discussed with that. It's very easy. Anyway, as we have taken the list of methods, let us see just one or two examples to each of those methods. Number one, direct substitution method. Observe the problem. Limit as x tends to 1 to x plus 3 by x square plus x plus 1. X tends to 1, that is either 0.9999 or 1.00001. It is approaches 1. Then this approaches 2 ones are 2, 2 plus 3, 5. 1 plus 1 square is 1, 1 plus 1 is 3. There is no harming in substituting x is equal to 1 here. No impossibility or no obscurity or no question of any trouble in evaluating it is there. Hence the answer is 5 by 3. One more. Limit as x tends to pi by 2 cos x by 1 plus sin x. What is that? What is cos pi by 2? 0. Sin pi by 2? 1. 1 plus 1? 2. Hence, as the denominator is not 0, we feel very, very happy for that. Hence, the answer is 0. Like that, there is nothing at all to discuss with this model. Direct substitution, which makes no harm at all by substituting the limit of x. Well, next one. Factorization method. Limit as x tends to 2, x square minus 5x plus 6 by x square minus 4. If you think of direct substitution, 2 square minus 4 is 0. So denominator is becoming 0. So it is a troublesome point here. You cannot substitute 2 in the place of x directly. Let us try to factorize the things. What is going to happen? Limit as x tends to 2. What is x square minus 5x plus 6? It can be taken as x minus 2 into x minus 3. And x square minus 4. What is x square minus 4? It is x minus 2 into x plus 2. automatically x minus 2 can be cancelled. Can it be cancelled? Surely. Why? Because x minus 2 is not 0. Who told us? X tends to 2. What does it mean? X is not equal to 2. X lies in the deleted neighborhood of 2. X can never be equal to 2. X minus 2 is not 0. Hence, we are permitted to cancel x minus 2. So that this is x tends to 2, x minus 3 by x plus 2. 2 minus 3 by 2 plus 2. Minus 1 by 4. The answer is minus 1 by 4. Like that. It is a very simple example, and here also there is nothing at all to discuss with that. Next one. We shall now discuss with those limits in which standard limits can directly be used. If I speak of standard limits, the very first one among them is a very famous limit, that is limit as x tends to a of x power n minus a power n by x minus a is equal to n into a power n minus 1. Limit as x tends to x power n minus a power n by x minus a is equal to n into a power n minus 1. One of the most standard limits whose proof is also known to everybody. The proof is also famous. Yes, let us see the applications of this formula. As saying limit as x tends to 1. What can it be? In the place of a, we have 1. A power n, 1 power n is 1. As x tends to a, x tends to 1. And in the place of n itself, in the place of a, we have 1. 1 power n minus 1 is 1. So that limit as x tends to 1, x power 5 minus 1 by x minus 1. What is that? 5. Limit as x tends to 1 of root x minus 1 by x minus 1 is half, because root x is nothing but x power half. One more thing, limit as n tends to infinity of nth root of x minus 1 by x minus 1 is 1 by n. 1 by n. Next, one more application. Well, one more thing, limit as x tends to a, x to the power of m minus a to the power of m by x to the power of n minus a to the power of n. What can we say about this? It is nothing but m by n into a power m minus n. It can be very easy to trace the answer simply by dividing both numerator and denominator by x minus a and applying this formula. Well, in the place of a, if 1 is there, what happens to the fate of this formula? Limit as x tends to 1, x to the power of m minus 1 by x to the power of n minus 1 is just simply m by n. Okay, multiply with minus 1 on both numerator and denominator. What happens to the fate of this? Limit as x tends to 1, 1 minus x power m by 1 minus x power n is again m by n. In fact, it is minus m by minus n, nothing but m by n. And there are so many applications to this formula. Let us observe one such application now. Limit as n tends to infinity. A beautiful problem, really a beautiful problem. What will be the answer for this? Previously, we have had a very simple formula, a cute formula. Limit as x tends to 1 of x power m minus 1 by x power n minus 1 is m by n. And limit as x tends to 1 of 1 by x minus 1 minus x power n by etc. is again 1. It is again m by n. Next, Observe this. I'm sorry to say, it is not limited as n tends to infinity. It is extends to 1. Let me try to simplify this. Even if without using any step or something, you will be able to have the step in your mind itself. What is the weight of numerator? 1 minus x into 1 minus x square into 1 minus x cube into etc. 1 minus x power n into 1 minus x power n plus 1 into 1 minus x power n plus 2 into etc. 1 minus x power 2n whole divided by 1 minus x into 1 minus x square into 1 minus x cube into etc. 1 minus x power n whole square it is. Thereby, one set of 1 minus x into 1 minus x square into etc. 1 minus x power n can be cancelled. Let me try to express it on board. Is equal to limit as x tends to 1 minus x into 1 minus x square into and so on 1 minus x power n into 1 minus x to the power of n plus 1 into 1 minus x to the power of n plus 2 into etc. 1 minus x power 2n by 1 minus x into 1 minus x square into 1 minus x cube into 1 minus x power n into again 1 minus x into 1 minus x square into 1 minus x cube into 1 minus x power n. What I mean to say is, you need not put this step actually, you can observe this in your mind, so that what is going to happen? This will be cancelled. Now you observe x tends to 1. 1 minus x power n plus 1 by 1 minus x n plus 1 by 1. 1 minus x power n plus 2 by 1 minus x square n plus 2 by 2. 1 minus x cube 1 minus x power n plus 3 by 1 minus x cube n plus 3 by 3. How? It is just nothing but this is equal to limit as x tends to 1 minus x power n plus 1 by 1 minus x into 1 minus x power n plus 2 by 1 minus x square into 1 minus x power 2n by 1 minus x power n. We could have noticed the answers for such things just previously, so that we can trace the answer for this as n plus 1 by 1. Here n plus 2 by 2. Next n plus 3 by 3. Like that and so on. The answer for the last limit is 2n by n. Let us trace them. This is equal to n plus 1 by 1, n plus 2 by 2, n plus 3 by 3, 2n by n. Well, the denominator is 1 into 2 into 3 into etc. n is nothing but n factorial. Let me do a very simple thing. This is equal to n factorial into n plus 1 into n plus 2 into and so on 2n divided by n factorial into n factorial. What I have done is, I have multiplied both numerator and denominator with the number n factorial. Yes, you observe the fate of numerator. What happens to that? This is just nothing but 2n factorial by n factorial into n factorial, that is n factorial whole square. You please recall that expression from binomial theorem or permutations and combinations or binomial coefficients. This is just nothing but 2ncn. A beautiful question and a beautiful answer it is. It is 2ncn. You please observe how beautifully we could have applied the standard limit here. Yes, This is the answer for this beautiful question. Like this, there are so many other questions also available by making use of the standard limits. We shall discuss with them in due course of time.